Hello, my name is Manuel Velasquez, and this is my project for the class. Today I'll be showing you, well, by the way, this is a solo project. So today I'll be showing you an IMS or Inventory Management System. So the goal and features. This is going to be part of the SRS document side of the presentation. Goals and features. So the goal is to create a small program that allows you to create new inventory items and manage the numbers to keep track of what they have in stock. So let's say you're in a business or grocery store, you gotta keep track of how many soups you have, how many clients you have, etc. Right? This keeps track. It's a inventory system. It keeps track of inventory. It's also to allow the user to be updated on when their items need to be restocked slash resupplied. The features of the app is as follows, or program, if you will. Features: add or delete items from inventory, personalized identification numbers for each product, low stock alerts, user login, inventory reports via Excel app, easy update and modification of program, runs on Windows and Mac, can be accessed via mobile as well. Requirements. On the functional side, users can log in and log out. Admins can add, edit, and delete product entries. Employees can update stock levels. System displays current inventory. Users can generate and download reports. And as for the non-functional requirements side, system must be easy to use. Pages must load in under 2 seconds and mobile responsive design. So it should work on your phone as well. This is now the SDD side of the documents, I believe. And so it's a 3-tier system layout using HTML templates along with Bootstrap, CSS, and JS to modify and allow for easy UI interaction. Flask application for web use using its Flask login features along with MySQL database storage to keep track of said program. CSS and HTML on the front end, Python / DB logic on the back end. Security and layout. This just shows you in order how the program would look for certain things, and it would verify the users, the product that's in stock, the reports, when to trigger alerts for an inventory update or low stock. So, and security wise, so authentication uses a username / password system, so it's bcrypt encrypted. Basically, it has admin employee roles. You have to have a username and a login in order to access the program. Authorization, role-based access, what I just mentioned, admin versus employee. And as for data protection, TLS encryption, so input validation to prevent XSS/SQLI. All that basically means is that if you don't have a username or a password, it will not let you into the program. There will be no access for that. And only an admin can, um, what's the word for it? Verify or approve new users registration. This is still into the SDD side of the documents, so limitation and design choices. So it has a HTML dashboard with navigable tabs for various purposes, including stock information, quantity, and editing options. Backend wise, applications has authorization and data collection via built-in SQL security measures and cloud data backups. Passwords are hashed. Database backups via MySQL dump. It's is using a Flask app method, so it's server rendered. And as for the decision of how the program will work, all routes, logic, and views live in one Flask project using Jinja 2 for HTML rendering. Basically, you have it in one folder with the Python in one file, all the Python in one file, and all the HTML, CSS, and Bootstrap side of the code in another file under templates. So the trade-offs is that every UI change requires backend redeploy, and rules must be added via code changes. So what that basically means is that while you can register it, you have to manually approve it, so via code change. Testing. The goal is to ensure the program works as intended with small delays as long as user requirements are met. type of testing: regression tests, unit tests, and black box testing. So we did a lot of hands-on type of testing. You know, if something broke or something didn't. Well, I did. Something broke, something didn't work. I would go back to the code, see what the issue was, or I would try to break it via the completed program already. Like I had maybe like 1,000 types of items in the inventory to see how much it would take. So stress testing as well. It was very play by ear type of thing. So the final standardized testing document results. SQL launches correctly via localhost after every coding change, so it works. Normal login functions via admin and new login users, so it works. Known errors. Sometimes when you would have a username, it would show up incorrectly, or sometimes it wouldn't just boot at all because something was missing with the code, with the app.python code. And sometimes the alert system would do the reverse. So instead of alerting you of low stock, it will alert you of healthy stock. So stock that doesn't need to be resupplied or ordered again. The threshold for passing the program was that the alert system must show at least a notification via alert tab. So you might not get a ding, it should show at least a little red bubble indicating that something needs attention. The app.py, which is the main Python file, must execute properly. The SQL host must be running in a virtual environment to allow the app to, you know, run on a server or in the internet. And the criteria for failure was that stock updates mishandles negative stock numbers. So if you're trying to subtract a certain amount of stock or show out there's an amount missing, if it doesn't uh, um, properly handle those numbers, then it fails the test. And the SQL server fails to update HTML onto dashboard, resulting in empty site. What I mean by that is that sometimes the server would not create tables properly for the HTML templates to show onto the site.